This conference will now be recorded.
Okay, so today we'll be starting with a new chapter that is pre-formulation. So, any idea what do you mean by pre-formulation? So, why you are going for pre-formulation and what is the need for pre-formulation?
To evaluate physical and chemical nature of the substituent used.
Yes. Okay. So in case of pre-formulation, it is mainly a process where you are using for optimizing a drug. So before you are actually formulating a dosage form, you will optimize a drug by determining its physical and chemical properties. So why you are going for determining or characterizing a physical and chemical property of a drug before formulation is in order to develop a safe, effective and stable dosage form. So before you are formulating a dosage form, when you want to develop a safe, effective, and stable dosage form, first thing is you need to characterize or determine various physical and chemical properties of the drug molecule. So that is the meaning of pre-formulation. Okay, so pre-formulation is a process of optimizing a drug which is mainly used in the phase of research and development. Okay, so it is the process of optimizing a drug by determining or characterizing various physical and chemical properties of the drug in order to develop a safe, effective and stable dosage form. Okay, so pre-formulation, before your actual formulation you will characterizing the physical and chemical properties of the drug molecule. Okay. So what are the objectives of the pre-formulation? Why you're going for pre-formulation? Okay. So the main objective of a pre-formulation is you will be determining or you will establish the physico-chemical parameters of any new drug entity. So when you get a new drug entity, you will determine various physico-chemical parameters of the drug. And next one is you will determine the kinetics and stability of the drug. Third one, you will establish the compatibility with common excipients. So that is very important. So when you are determining the physical and chemical properties of the drug, it is also important to check whether your drug is compatible with the various excipients what you are using in the formulation. So if your physical chemical properties of the drug is fine and if it is not compatible with the excipients what you are using, then whatever you are doing, formulation will be of waste. So there should be a fair compatibility between the excipients and drugs what you are using. And also it will provide the pre-formulation characterization will provide how the drug molecules has to be processed and how it has to be stored in order to ensure the quality. So these things can be determined when you are following the pre-formulation protocol. So first thing is you can establish physico-chemical parameter, you will determine the kinetics and stability of the drug, and you will also establish the compatibility profile between the drug and various excipients what you are using. And finally, you will come to know how the drug product has to be processed and how it has to be stored to ensure the quality of the dosage form. So major area of formulation research. So what are the area that you will be characterizing when you're going for pre-formulation? So the first one will be organoleptic characters. So the odor, taste and color of the product will be determined. So once the organoleptic characters is done, you will go for bulk characters of the drug. So what are the different bulk characters that you will be doing? It will be checking the crystallinity and polymorphism of the drug, hydrophobic of the drug will be determined, and find particle characterization. So how the particle will be distributed. So that will be determined, and flow property of the drug will be determined. So these are the four different bulk characters that will be determined: crystallinity and polymorphism, hygroscopicity, fine particle characterization, and powder flow properties. And next, so once the bulk characters you determine, the other area of research is solubility analysis. Solubility analysis of a drug is very important. So how you will determine the solubility analysis? First one is you will determine the ionization constant, that is by pK determination, and you will go for pH solubility profile, and common ion effect of the drug will be determined, and thermal effect. So these are some of the solubility analysis profile of the drug what you will be doing. And so when you're going for solubility analysis, the one more thing, the important one is solubilization. If the drug is poorly soluble, what is the method you will use to increase the solubility of the drug? That comes under your solubilization, and partition coefficient of the drug will be determined. So once partition coefficient is determined, the next one is dissolution of the drug. So dissolution is very important, right? So in order to get a maximum absorption of the drug, dissolution will be very important. So these things will be studied under your solubility profile. And last one will be stability analysis. So how the drug is stable, whether the drug is stable or not. So its toxicology will be studied, and solution. So when the drug is formulated in solution, whether it has a good stability, and pH rate profile at different pH, what will be the stability of the drug will be determined, and in solid state, or the stability will be determined, and bulk stability of the drug. Finally, the compatibility of the drug with various excipients will be determined. So these are the three major concerns. So one is organoleptic characters, bulk characters, solubility analysis, then stability analysis will be done. Okay. So once you are determining this, once the organoleptic characters is determined. So what are the different organoleptic characters I told? So what may be the different organoleptic characters that you will be determining?
Odor, taste, smell, taste,
Huh.
texture.
Huh.
Color.
What are the different colors that you can be telling when you are seeing a drug? Different color types.
White, and
Huh.
yellow.
Then, so one can determine it. It will be characterized that white, off white will be there, and cream, yellow, or tan, shiny. So these are the things what you'll be determining in when you are telling about color. So when you are going for punch odor,
Pleasant odor, a pungent odor, uh,
then only pungent. Any other odor characterization that you will be doing? No? Okay. So when you go for color, just a minute. So when you're going for color, it is you will be checking whether it is off white, white, cream, yellow, tan, shiny, etc. These are the different colors what you'll be checking. And when you go for odor, so you'll check whether this drug is pungent, whether it is sulfurous in its odor, it is fruity, aromatic, or it is odorless. And when you go for taste, you'll be determining whether it is acidic in taste, bitter in taste, or whether it is bland, sweet, tasteless. So these are the things what you'll be doing for organoleptic characters, and this may vary from person to person. Okay, so I may feel that the color is off white, somewhere it is cream, so it will vary. So this is not an exact classification what you'll be doing. So in order to get determined characteristics, apart from organoleptic characters, there are different things what you'll be doing. The first one is bulk characterization or crystallinity. So what do you know about crystallinity? Any idea? Crystallinity? No?
crystals have a definite structure.
Yes. So what do you mean by crystal lattice? Anything about crystal lattice?
Ma'am, arrangement of
Arrangement?
particles,
Yes, yes.
no,
Okay.
definitely.
Yes, correct. So when you're going for crystallinity, you will be studying crystal habit. So crystal habit and internal structure. So crystal habit of a drug is nothing but the outer appearance of a crystal. So how the crystal will look. So that is what you will be studying in crystal habit. So internal structure is the molecular arrangement within the solid. So these things, the differentiation you have to know. So one is crystal habit, the other one is internal structure. So crystal habit is the outer appearance of the crystal, whereas when you go for internal structure, it is the molecular arrangement of crystal within the solid. So how it will be arranged within the solid. Okay, so any change with the internal structure will obviously alter the crystal habit. So inside, if there is any change in the internal structure or molecular arrangement within this crystal, obviously the outer appearance will also be changed, right? So example, when you go for conversion of sodium salt, so sodium salt when it is converted into its free acid, both the crystal habit and the internal structure both will be changed. So once you are changing the internal structure, the crystal habit will be changed, and once the crystal habit is changed, even the internal structure will be changed. So why you are studying this crystal habit and internal structure is, so there are crystal habit and the internal structure of a drug will affect the bulk and physicochemical property of the drug. The bulk characteristic of the drug or the physicochemical property of the drug will be altered once the crystal habit will be changed. So a very important phase of pre-formulation will be the determining of crystal forms and its polymorph. So what do you mean by polymorph? Polymorphism you have studied, right?
Yes, ma'am.
So what do you mean by polymorphism?
The ability
When
of the form different uh, lattices.
ability of
Crystals to form types of lattices.
ability of a compound to crystallize as more than one distinct crystalline species with different internal lattice. So there will be different crystalline forms with different internal lattice. That is called as polymorphism. So there are two main two crystalline forms are called as polymorphs. So there are two main types of polymorphs. One is enantiotropic, the other one is monotropic. What do you mean by enantiotropic? I think these things you have studied already. So what do you mean by enantiotropic? No, don't know.
DML.
Hmm? So anisotropic is when you are varying the temperature or pressure, one polymorphic form of the drug substance will be reversibly changed to another one. So when it is changing reversibly, it is called as anisotropic. So just by varying the temperature or pressure, one form will be converted into another form in a reversible manner. But monotropic is one polymorphic form will be unstable at all temperatures and pressure. So it will not be stable at any temperature and pressure. So that is called as monotropic. So one particular polymorphic form will be unstable. So when you are converting, I told in case of anisotropic, by varying the temperature or pressure, one form will be converted into other. So when it is converting from one form to another form, one of the polymeric form will be stable. The other form will be unstable. The unstable form is called as metastable compound, whereas one will be stable, the other one will be unstable. So unstable is called as metastable. Remember that. So the unstable form of the polymorph is called as metastable. Because it is already 11:20 within 40 minutes. The screen is not visible.
No, ma'am. It's gone.
So I'm going to share the link. Just a minute. Please turn on your videos. So MCQs are there. Whatever correct is there, that only you have to choose. Okay. Turn on your videos, everyone, please. Okay, first, crystal habit and internal structure are told that will affect the bulk and physicochemical property of the molecule. So, crystal habit is the description of the outer appearance of a crystal, whereas when you go for internal structure, it is the molecular arrangement within the solid. So, once there is change with the internal structure, usually it will alter the crystal habit. So these are the different types, shapes of crystal what you'll get in a drug. So the drug may be in a cubic crystal or it may be tetragonal, it may be triclinic, orthombic or hexagonal, monoclinic, trigonal. So these are the various shapes of the crystal. Next, so when you go for different shapes of crystals, there are two main shapes of crystals where it is classified as crystalline and amorphous. So you know, so in case of crystalline compounds, it is characterized by repetitious spacing of the constituent atom or molecule. So it is a three-dimensional array when you go for crystalline compound. So it is a three-dimensional array and you will have repeating spacing of the atom or molecule. Whereas when you go for in amorphous form, the atom or molecule will be randomly placed. So crystalline, it is a three-dimensional array, whereas in amorphous form, the atom or molecule will be placed randomly. So always the solubility and the dissolution rate will be greater for amorphous form than in case of crystalline. Why? Because amorphous form has a higher time thermodynamic energy. You should know this. So they may ask, so you know that amorphous form has a greater solubility or dissolution characteristics. Why? Because it will have a higher thermodynamic energy compared to the crystal form. Example is amorphous form of novobiocin is an antibiotic will be well absorbed, whereas crystalline form results in poor absorption. So that is the one example what you can put. Novobiocin, when it is in amorphous form, it is absorbed well, whereas when it is in crystalline form, it will show a poor absorption because the amorphous form of novobiocin has higher thermodynamic energy compared to your crystalline form of novobiocin. Okay. So next one I was telling about or talking about polymorphism. So polymorphism is the ability of a compound to crystallize as more than one distinct crystalline species. So the same compound will crystallize in more than one crystalline species and each crystalline species will have a different internal lattice. So the different crystalline form is called as polymorph. You have two types of polymorph. One is enantiotropic, the other one is monotropic. So I told in case of enantiotropic, one polymorph will be changed into another just by changing the temperature or pressure. Example is sulfur. So sulfur, when you are changing the temperature or pressure, it will convert into various polymorphic forms of the sulfur. But in case of a few polymorphs, it will be unstable at all the temperature and pressure. Example is your glyceryl stearate. Okay, so it will be unstable even if you are increasing temperature or lowering temperature, it will be unstable. So these two examples you have to remember. An anisotropic example is sulfur and monotropic example is glyceryl stearate. Okay, so why you are going for polymorphism? So what is the use of polymorphism? So polymorphism differs from each other with respect to their physical property, such as stability. So I told when you have two forms of sulfur, so each form will be different from other in its solubility characteristics or melting point, density, hardness, and compressible characteristics. So when you are going for pre-formulation study, you have to, when you are selecting the drug, first thing is you have to check in which polymorph is it is there, whether it is an enantiomer or whether it is an monotropic form. First you will be checking that. And in case of enantiomer, there will be different types of crystals. So each form, which form is more stable and what is the melting point of the form. So everything will be determining. So that is the importance of polymorphism. Why you are going for polymorphism? Because each polymorph will differ in their physical property. So based on the suitability, you will be selecting the particular polymorph which is necessary for the formulation. Solubility, melting point, density, hardness, and compression characteristics will be differing. Okay, so when you go for chloramphenicol, so chloramphenicol, it will exist in three different polymorphs. So A, B, C. So out of A, B, C, you are selecting B form because B form is more stable compared to other A and C. So this is the reason why you're going for the study of polymorphism. So only one of the polymorph will be more stable compared to other. So the stable polymorph we will be selecting for the next formulation. Okay. So I told when you are converting or when you are varying the temperature and pressure, one polymorph will be converted into another. So in that, only one will be stable, the other form will be metastable or unstable. So remember the unstable form of the polymorph is called as metastable polymorph. And this metastable form, crystal will always have a lower melting point and higher solubility. That is what you have to remember. So the metastable form will be having higher solubility, whereas it will have a lower melting point. Okay, so how you will study this crystals? So you need to check which crystal will be more stable. So the different methods what you'll be using for characterizing of crystals are, you'll be using microscopic method, you'll be using hot stage microscopy, thermal analysis will be done, or infrared spectroscopic method will be used, proton magnetic resonance will be used, or NMR, nuclear magnetic resonance, or scanning electro microscopy. So these are the methods will be generally used in order to determine whether the polymer what you have selected is stable or not. So this we'll be studying in your later slides, okay, how it will be carried out. So microscopy. So why you are going for microscopic method? So microscopic is also, it will also determine when the material will have more than one refractive index. So the same material, when it is having more than one refractive index, that is called as anisotropic. Okay, so this you have to know. So the same compound which is having more than one refractive index is called as anisotropic, and these anisotropic compounds will appear bright with brilliant colors against black polarized background. So when you have a background which is black, this anisotropic compounds will appear as bright. Okay, so and next one, isotropic material. So unlike your anisotropic, this isotropic material will have only single refractive index. Okay, and this isotropic material will always, this is a substance which will not transmit the light. Okay, it will appear black. So what I told in case of anisotropic will appear bright with brilliant colors, whereas isotropic will appear black in color. So and next one. So what is the advantage of this microscopy? So by this method, you can study the crystal morphology, and you can also differentiate between the various polymorphic forms. So we can determine whether it is anisotropic or whether it is polymorphic form. So but what is the disadvantage of this method is you need to have a well-trained optical crystallographer to, when you want to differentiate a polymorph. So you require a well-trained person for this. Okay, because each crystal habit, there will be as many as possible crystal habits, and there will be different appearance at different orientation. In order to determine this, you require a well-trained optical crystallographer. So this is how a microscopy helps. So microscopy will also determine the material which is having one refractive index and more than one. So the compounds which is having more than one refractive index is called as anisotropic, and the compounds which is having single refractive index is called as isotropic compound. So next one is hot stage microscopy. So why are using hot stage microscopy, and what is the use of this hot stage microscopy is, so even this is used for determining the crystal habit and different polymorph. So what you will do in this case is, the normal polarizing microscope will be fitted with a hot stage, which is useful for investigating polymorphism. It will investigate the polymorphism, and it is used to determine the melting point and transition temperature also. But So what is the disadvantage of this hot stage microscopy is in this technique, the molecules have a tendency to degrade during the melting process. So you are heating the molecule. So this may lead to the degradation of the molecule during the melting process. So you are heating the crystal. So this will degrade the molecule. So hot stage microscopy, what are the three main uses? You can determine the melting point, transition temperature, and even it is used for investigating the polymorphism. So what is the disadvantage? So the disadvantage is that in this technique, the molecules can degrade during the melting process. So next one is thermal analysis. So how you will do the thermal analysis? You will be using differential scanning calorimetry or and differential thermal analysis method will be used for investigation of polymorphism. So in this thermal analysis, you will measure whether the compound has measure the heat loss or heat gain resulting from physical or chemical changes within the sample. So when you are increasing the temperature, whether particular compound has gained heat or whether it is losing heat. So this will be the what you will tell. You will measure the heat loss or gain during the physical and chemical changes. So when a compound or when a crystal is undergoing some physical or chemical change, obviously there will be loss of heat or there may be gain of heat also. So this you will determine and this will give you the polymorphism characteristics. So whenever you are characterizing the crystal form, the heat of fusion can be obtained from the area under DSC curve. So you'll be studying this in the higher classes, differential scanning calorimetry, you will get a curve. Okay, so this curve will give you the heat of fusion for particular crystal habit. So but at this point it will be more for you. So just remember thermal analysis, how you are doing, you are using differential scanning calorimetry or you will be using differential thermal analysis. These two are particularly useful in investigation of polymorphism. So what they will do, it will give you the measure of heat loss or heat gain resulting from physical or chemical change of a sample as a function of temperature. So you can also calculate the heat of transition from one polymorph to another. So when it is converting from one polymorph to another form, the heat of transition can also be calculated. So when you get after this thermal analysis, you will get a curve. So when you have a sharp symmetric curve, melting endotherm, that will indicate the relative purity of the molecule. But when you get a broad asymmetric curve, that will indicate the presence of impurity. So this is very important. So when you have a sharp symmetric melting curve, so it will give you or it will indicate the relative purity of the drug. But the broad asymmetric curve will indicate the presence of impurity within the compound. Okay, so now I'll just glance. So what do you mean by polymorphism? Sorry, what do you mean by preformulation first? So what do you mean by preformulation? Brief answers. What do you mean by preformulation?
Analyzing and modifying the structural, chemical, and physical properties of a drug.
Why you're going for preformulation? So what is the need to study the physical and chemical properties of the drug? Yes, why you're doing preformulation study? Simply you will determine the physical and chemical property of the drug. There is no use. What is the main objective? Why you're doing this?
To find the find the physical and
Yes, correct.
physico-chemical
You are
property
right.
of new.
Yes, you will determine the physical and chemical property. Why you need to determine the physical and chemical property of the drug? That is my question.
in order to develop a safe and
Yes, yes,
stable drugs.
yes, correct. In order to develop a safe, efficacious drug, will be going for pre-formulation studies. Okay, so what do you mean by crystal habit? What do you mean by crystal habit?
The outer appearance of the crystal.
Internal structure?
The molecular arrangement within the
Yes,
solid.
correct, correct. What do you mean by polymorphism?
Ability of the compound to crystallize in more than one crystalline species.
Yes, correct. What is the difference between anisotropic and monotropic compound?
An anisotropic has a 2 refractive index.
That is what you're telling is anisotropic. Refractive index will come under anisotropic and isotropic. Anisotropic will have more than one refractive index, and isotropic will have only one refractive index. So what you're telling is this for that. What is
Okay.
for sorry anisotropic?
An anisotropic can be changed from one form to another form, ma'am,
When you can
by
change from
varying
one form to another
temperature,
form?
or pressure.
Pressure. The stable form, what is the other name for unstable form of a polymorph?
Metaph
Metastable. Okay. Next one. So thermal analysis you'll be doing. So thermal analysis, what you have to remember, the sharp symmetric melting curve will give you, which will indicate the relative purity of the molecule. When you get a broad asymmetric curve, it will indicate the presence of impurities. Okay. Next one is hygroscopicity. So many drug substances, particularly when you go for water soluble salt forms, will have the tendency to absorb the atmospheric moisture, so that we have studied. So most of the molecules will tend to absorb the atmospheric moisture. The absorption and moisture content depend upon the atmospheric humidity. So what is the humidity condition in the atmosphere, what is the temperature, surface area of the compound, exposure, and the mechanism of moisture uptake. So these are the things that will determine the absorption and moisture content of a compound. So how you will explain the degree of hygroscopicity? So hygroscopicity is when you will tell a compound is as slightly hygroscopic. Hygroscopic when there is increase in weight, more or less when it is between 0.2% weight by weight to less than 2% weight by weight, it is called as slightly hygroscopic. But when a compound is increased in its weight about 0.2 to 2% to 15% weight by weight, then it is said to be hygroscopic. Very hygroscopic means the weight of the compound will be increased by 15%, more than 15% weight by weight. Deliquescent is sufficient water is absorbed to form a solution. The compound will be converted into solution form after absorbing the moisture. So these are the four classification of a hygroscopic substance. So what is hygroscopicity? So hygroscopicity is a phenomena where the molecule will absorb the atmospheric moisture. So what are the conditions or factors that will affect the absorption of moisture? One is atmospheric humidity, the other one is temperature, surface area of the drug molecule, exposure, and which mechanism it will adopt for the moisture uptake. So how it is classified? Four different classification. One is slightly hygroscopic, very hygroscopic, and deliquescent. So slightly hygroscopic is the compound will increase in its weight after the absorption of moisture by 0.2% weight by weight to less than 2% weight by weight. So hygroscopic, when you will tell a compound as hygroscopic, when after absorption of the moisture, if its weight is increased by between 0.2% weight by weight to 15% of its virginal weight. Next, very hygroscopic, the increase in weight will be more than 15%, and deliquescent is it will be converted into solution after the absorption of the moisture. So how you will determine the hygroscopicity? So what you will do, you will take the sample. The samples will be exposed to moisture. After exposing to moisture, you will expose the sample at a controlled relative humidity environments, and then you will weigh the sample, or you will determine the moisture uptake at different time points. So what are the methods that you'll be using for determining the hygroscopicity is, so the three main methods what you'll be using is gravimetric method will be used for determining the hygroscopicity, Carl Fisher titration method, and gas chromatographic method. So these three methods will be used for determining the hygroscopicity of a sample. Okay, so next one is, so after you know a sample whether it is hygroscopic or not, so you will use the three methods and you will check whether the particular compound what you are using is hygroscopic or slightly hygroscopic or deliquescent. So that will be determined, and then will be your particle size. So particle size is very important when you are going for any formulation of the drug. So why particle size is very important? So the particle size is very important because it will influence various other factors of a drug, the dissolution rate of a drug, or suspendability, or uniform distribution of the particles, penetrability of the particle, and it should be there should be lack of brittleness. So this all will depend upon the particle size of the drug. So that is why it is very important to characterize the particle size. So how you will characterize the particle sizes? So you can characterize it as very coarse powder, or coarse, moderately coarse, or you can also tell it as fine and very fine. So these are the different characterization of the particle. So it is very coarse, coarse, moderately coarse, fine, and very fine. So the even the particle size, I told it will determine the drug dissolution rate, absorption rate, suspendability, and even the content uniformity or uniform distribution, taste of the drug, texture of the drug, color of the drug, and stability of the drug will also be dependent upon the particle size of the drug. So what are the different methods you will be using for determining the particle size? The different method used for determining the particle size is sieving method. So where you can determine the particle size around 5 micron to 150 micron. Microscopic method, 0.2 micron to 100 micron particles can be determined. Sedimentation rate method, 1 micron to 200 micron. Light energy diffraction method, 0.5 micron to 500 micron, and laser holography method you'll be determining from 1.4 micron to 100 micron. So when you go for sieving method or okay, sieving method or screening is probably what you are used for, from the oldest method of sizing particles, and still now it is used to determine the size distribution of the powders in the same size ranging from 44 micron. So this you have done in your engineering. So mainly sieving method is used for determining the particle distribution also. So this will give you a rough idea, or when you are sieving, it will give you a rough idea of the particle size when you are evaluating a raw material. So basic disadvantage of screen analysis are large sample size you will be requiring, and so you cannot determine very minute particles. So the size range will be more. So I told it is from 5 micron to 150 micron. The size range will be more, and it is relatively low cost. That is one of the advantage compared to other methods. It is relatively low in cost, and it is simple compared to other methods. So but disadvantages, you can determine only from 5 micron range, so the size will be more. So although microscopic method, you can determine the size from 0.2 micron to 100 micron. So it is universally accepted, and it is direct method of determining the particle size distribution of powders. Okay, so you can directly mount the powder under the microscope, and different resolution you can determine. It is from 0.2 micron to 100 micron. So, but one thing in microscopic is, so the preparation of the slide for counting the particle is of major importance because the sample on the slide must represent the particle size distribution of the bulk powder. So you have a large powder in bulk. So the powder what you are taking should represent the whole powder. So like that you will be preparing the slide. So whatever result you will get, it will be correlated with the bulk powder what you will be having. So how you will do is, in this case, you will blend the random samples you will be taking from the bulk powder, and after taking the random sample from the bulk powder, it will be reduced. The sample size will be reduced, that is less than 0.5 gram, and then again it will be reduced by quartering it, and the sample will be suspended or it will be dispersed, and it will be thoroughly mixed in the liquid which is having different refractive index, and then it will be counted under the microscope. So you are taking the sample from the bulk, and then once the sample is taken from the bulk, you will reduce the sample size. So the sample size will be very minute, and then it will be mixed or it will be dispersed with a liquid having different refractive index. Okay. Next one, when you go for sedimentation rate method, so you will be using Stokes equation to describe the relationship between the rate at which the particle settles in a fluid medium to determine the size of the particle. So I had told when I was telling about Stokes equation, so larger the particle size, what will happen? The sedimentation will be faster. The same principle will be used when you are going for sedimentation rate method. So the Stokes law will give you a relationship between the rate of sedimentation of the particle in a fluid medium to the size of the particle. And this covers a range from around 1 micron to 200 micron, and sometimes even to 250 micron also. So how they will be doing the sedimentation method is, usually they'll be using Anderson pipette apparatus. So in Anderson pipette apparatus, first you will prepare a solution, and in Anderson pipette, you will just pipette out exact volume of the sample will be withdrawn. Okay, so from a specified liquid depth. So I told you are taking the sample and it will be suspended in a suitable liquid medium, and from that liquid solution what you have prepared using Anderson pipette, you will be withdrawing specified or exact volume of sample from the specified liquid depth. And once you are getting the suspended medium will be evaporated and the sample will be weighed. So when you are weighing the sample, it will give you the amount of sample that is settled down. So I will send you the Stokes equation which is used for this. So using this Stokes equation, they will determine the amount of particles or the size of particles that has been settled at a particular time. Why you require powder flow properties? What is the use of powder flow properties? How you will determine the flow property of a powder? This year
by
study
find,
there? Yes. Tell me.
by finding the angle of repose.
Yes. So one method is you will be determining the angle of repose by fixed funnel method. So what is the need of determining the powder flow properties? And powder flow property, again, it will be affected by change in particle size, shape, and density. Once the particle size of the drug or the shape of the drug or even the density of the drug is changed, it will again alter the flow property of the powder. So the flow property will also depend upon the force of friction between the particle and cohesion between the particle. So one particle to another. So what is the cohesion force between the particle and what is the force of friction? So this will depend, it will determine the flow property of the particle. So when you have fine particle, which sometimes it will show the poor flow because by filling the void spaces between the larger particles. This will cause packing and densification of the particles. This is the reason why the fine particles will possess poor flow. So fine particles possess poor flow by filling void spaces. What do you mean by void spaces?
The empty space between the particles.
So between the larger particles, there will be empty spaces called as void spaces, and this void spaces will cause the packing and densification of the particles, which will determine the poor flow for the fine particles. So how you can increase the flow property of a poorly a powder which is having poor flows by adding talc. So I think this you have studied already. I will not go in deep. Now we will determine the angle of repose. It is tan theta is equal to h by r. Theta is equal to tan inverse of h by r. So where h is height of the pile, r is the radius of the pile, and theta will give you the angle of repose. Okay. So usually the greater the angle of repose indicate the poor flow. So when you have lesser angle of repose, which is less than 30, will give you a better flow. So less than 25 it is said to be excellent flow, 25 to 30 it is good flow, 30 to 40 if you get the angle of repose it is passable, and more than 40 if you get the angle of repose then it is said to be very poor flow. So this you have studied. I think you have done the fixed cone method or funnel method, what you will be doing. So there are different methods which is used for determining the angle of repose. The first one will be static angle repose, or it is where it is determined by again two methods. One is fixed funnel method and fixed cone method, and kinetic or dynamic method. In that you will be using rotating single cylinder method, or you will be using tilting box method. So we will be discussing in the next class. So these are the methods what you will be using for determining the angle of repose. So those who have not submitted the assignment till you have time today, you can submit it. Okay, so your classes will be resuming, I think, from November 2nd. So whatever questions I have given for you, please study that. The next, whenever you have class, you will be having test. I think November 2nd only you will be having the class. You will have the test on liquid orals. The questions what I have studied, you read that, and along with that, I will be giving few MCQs also. Okay. Okay. Bye everyone. Happy Dasra to all. Enjoy.
Thank you, ma'am. Same to you.
Thank you.
Thank you, ma'am.